and welcome back. Mrs. Saunders here. Today we're talking about congruent polygons and then more specifically congruent triangles. Now before we start, you might want to grab some colored pens or pencils for this lesson because I use a lot of colors to keep some of the information straight in my brain, and you might want to do the same. If two geometric figures have the same size and shape, they are congruent. So here's a bunch of congruent figures. See, same size, same shape all over here on the left. On the right though, not same shape, not congruent, not same shape, not same shape. Same shape, but not same size. So those are not congruent. And then not, well, same shape kind of, but kind of wonky. So congruent, same size and same shape. Now, two polygons are congruent if and only if their corresponding parts are congruent. So here are two triangles, and I'm going to tell you that triangle XYZ is congruent to triangle RST. So that means that angle X is congruent to angle R, and angle Y is congruent to angle S, and angle Z is congruent to angle T. Those guys are all partners, and the order of the letters is really important. That's sort of like your roadmap to what pieces and parts are congruent. Now let's look at the sides. Once we have the angles in place, then we can also know that XY is congruent to RS, XZ is congruent to RT, and YZ is congruent to ST. This says show that the polygons are congruent by identifying all congruent and corresponding parts. Then write a congruence statement. So just look at those a sec, and you'll notice that angles A and J both have one arc. So those are congruent to each other. A congruent to J. And then B and K, those both have two arcs. And then C and L, those both have three arcs. So those are the sets of congruent angles. Now let's look at the sides. So we can connect A and B and J and K. AB is congruent to JK, BC is congruent to KL, and AC is congruent to JL. So we know that triangle ABC is congruent to triangle JKL. That's the congruence statement. One more like that. This one's a little bit harder because it's kind of mirrored. So let's look at the sides first. These two have just the one marking, so those are congruent. And then FG, LK, those have the two little lines, so those match up. And then FE and KJ. This time we did the sides first, which is fine. And then we know that the right angles are congruent, so F and K. And then with that, now we can kind of see that like angle E and J, those are partners, those are congruent, and G and L. And so now we can list all of the corresponding parts. So E is congruent to J, F is congruent to K, G is congruent to L, and then the sides as well. EF to JK, FG to KL, and GE to JL. So our congruent statement then is that triangle EFG is congruent to triangle JKL. All right, now let's add some numbers and some variables to this. This says, suppose that triangle ABC is congruent to triangle DEF. Find the value of X and find the value of Y. Well, there's information all over the place. So the first thing we need to do is figure out which parts are congruent to which other parts. And this is when the order of the letters is really important. So A and D, those partners. So I can say that those are congruent. And then BE, those are next. So I can mark those. And C and F, those are congruent. So see how these colors kind of can keep everything organized in your brain. Now I can figure out, okay, I need to find the value of X. So there's an X, and the partner to that side between like the pink dot and the purple dot on the other triangle is 90.6. So I know that those segments are congruent. So 2x plus y equals 90.6. Now we have a problem. We have two variables there, 2x and then the y. So just pause that for a second, and maybe we need to go find the value of y first. So this green part says 2y minus 5, and its partner is over in A, right? That's 65 degrees. So I can say that 2y minus 5 equals 65. Now I can solve for y, add 5 to both sides, divide by 2, so I get y equals 35. Now that I know y equals 35, I can go back up and plug that in. I can plug that in for the y right here. Okay, so 2x plus 35 equals 90.6. Subtract 35 from both sides and divide by 2. So x is 27.8. We solved that one. All right, this one, we've got a polygon, BCDE, and it's congruent to polygon RSTU. And we need to find the values of W, X, Y, and Z. And again, there's so much information, so use those colors to organize your brain. The order of the letters is really important. So B partners with R. C partners with S. D partners with T. And E partners with U. All right, now let's find the W. There's a W there and a W there. And are those between the same colored dots? That's the question. And yes, those are congruent segments. So we can say that 4W minus 7 equals 2W plus 13. So you subtract 2W from both sides, add 7 to both sides, divide by 2. So we've solved for W, that's 10. Now let's see if we find the X's. There's an X there, and its partner, the other green dot, is 49. So we know that 2x plus 9 is 49. Subtract 9 from both sides and divide by 2. So we found that x is 20. Next, let's see if we can find the y's. So there's one here on the purple dot, and the other purple dot also has a y. So they're both on the purple dots. Those are corresponding angles that are congruent. So we can set those equal to each other. 2y minus 31 equals y plus 11. We'll subtract y from both sides and then add 31 to both sides, and you get y equals 42. And then one more we need to find is z. So z we've got between purple and dark green. So 3z plus 10 equals z plus 16. We're going to subtract, let's see, subtract 10 from both sides, subtract z, and we get 3 equals z. All right, now that's the end of that lesson, but before we leave today, we're going to do a little bit of a review on inequalities, because as we get deeper and deeper into triangles, we're going to need this skill set here. So we're going to look at inequalities, and we're going to look at them on a number line. And maybe you learned some of this in Algebra 1, so hopefully this is a bit of a review. So looking at the number line, I can pick two dots, two spots on the number line. I'll pick -5 and 3. And if I were to write an inequality, I could do it in two ways. I could say that -5 is less than 3, or I can say that 3 is greater than -5. Let's pick two more. We've got -1 and 10. Again, we can say this in two ways. I can say that -1 is less than 10, or I can say that 10 is greater than -1. Let's make it a little bit more complicated, shall we? What if I tell you that x is less than or equal to 3? I want a number that's less than or equal to 3. So anything on the number line that's below or to the left of 3 would apply. Does 3 count too? It says less than or equal to 3. So yeah, 3 would also count. So I'm going to put a closed dot there. Let's try x greater than 7. So this time, anything to the right of 7 on the number line would be what I'm looking for. Is 7 included? It says x greater than 7, but not greater than or equal to 7. So 7's not included. I'm just going to put an open circle on that. Okay, adding a little bit more complication now. If I tell you that x plus 3 is less than 2, how do we solve that inequality? For right now, we're just going to treat it like a regular equation. I'm going to subtract 3 from both sides, and I get x is less than -1. So anything to the left of -1, but not including -1. All right, 5 times the quantity, x minus 5, is greater than or equal to negative 5. So again, just treat it like a normal equation for right now. So we're going to distribute that 5. We get 5x minus 25 greater than or equal to negative 5. I'm going to add 25 to both sides and divide by 5. So x is greater than or equal to 4. Now, I said to treat it like an equation, like a normal equation just for now, and we have. But there is one trick that I need you to be aware of, and that's multiplying or dividing by a negative. There's something special we have to pay attention to here. So if I have 3 minus 2x is greater than 7, we can start it off normal. I'm going to subtract 3 from both sides, and then I get negative 2x is greater than 4. Now, here's the thing you have to be aware of. When you multiply or divide by a negative number, you have to flip the inequality sign. So when I divide both sides by negative 2 to get x by itself, notice how I flipped the inequality sign. So here was greater than, and when I divided by the negative 2, I had to make this a less than sign. So if we plot that on the number line, I've got x is anything to the left of negative 2, but not including negative 2. All right, let's try another one. We've got the distributive property here. So we're going to start just like we would a normal equation. So we'll distribute the 3. We've got 9 minus 3x is less than or equal to negative 6. We're okay so far. We'll subtract 9 from both sides. So we get negative 3x is less than or equal to negative 15. And now, in order to get x by itself, here we are. In order to get x by itself, I have to divide by this negative. Now you can add and subtract negatives all you want, but it's multiplying or dividing by a negative that you have to be careful of. So in order to get x by itself, I'm going to divide both sides by negative 3, and when I do that, I'm going to flip the sign. So what was less than before is now a greater than, and I've got x is greater than or equal to 5. Because this negative disappeared when I divided it by that negative. And we can plot that on the number line, anything to the right of 5 and including 5. So that's a quick review of inequalities. Thank you so much for being here, and I will see you next time.